Hello everyone. Today we want to talk about the idea of the abstract algebra. So what does abstract algebra study? Uh, Generally speaking, the abstract algebra studies the algebraic structure. So what is algebraic structure? First, let's look at some examples. 1 plus 1 is 2 and 2 plus 1 is 3. This is what everyone knows. And if you have an apple and I give you another apple, then you will have 2 apples. And the following is a very easy question in primary school. That is around plus around is a triangle. Around plus a triangle is a square. So a square is equal to how many rows? The answer is certainly 3. Yeah. So what are the common features of these examples? The mathematicians abstract the concept of a set and operations. So what is a set? A set is a basket which contains some toy bricks. These toy bricks are called elements. And what is an operation? An operation is a way to combine small bricks to get larger bricks. That is, we can peel them up or glue them up to get larger bricks and use these bricks to create some artworks. And now we should distinguish two concepts. One concept is concrete models, and the other concept is the abstract structure. So, what is abstract structure? Abstract structure is a set with some operations. This is an abstract concept, and you can just imagine it as a basket with some toy bricks. And the concrete model is something satisfies the rule that we define in this set. For example, if we define a toy structure as a set with an operation plus, and we see that the three examples above, 1 plus 1 is 2, 2 plus 1 is 3, that is the numbers, and the apples or the shapes satisfy the toy structure. More precisely, an algebraic structure is a set with some operations that satisfy certain conditions, and these conditions are useful for mathematicians to prove the properties that these algebraic structure have. And generally speaking, if we have more operations and more conditions, then the algebraic structure is more complicated, and then we can create more beautiful artworks. To explain this, we can consider an example. Consider that we have many toy bricks, and first we can peel them up to create some artworks. And then one day, if we find that the operation peel can't satisfy our request, then we can try other operations. For example, we can glue them up and use the new operation glue. We can create more artworks, use these bricks. So algebraic create many baskets with toy bricks, and then define different operations and conditions over these baskets. Formally speaking, they are groups, rings, algebras, vector space, and so on. And so the mathematicians play with these abstract structures, then infer the properties that concrete models have. To explain this idea, we watch an example. Everyone knows that a cat will have two eyes, one tail, and so on. And one day, if my father tell me that he buys a cat for me, and then even though I haven't seen the gift cat, I know that my gift will have two eyes, one tail, and so on. So this is that if we know a property that the abstract structure will have, then we can infer that the concrete models will have the same property. So this is what mathematicians do. Suppose that the set of integers is denoted by z, and z has a free abelian group structure, and the mathematicians will prove that all subgroups of a free abelian group are free. Then they know, aha, all the subgroups of the set of integers z are also free. So this is the general idea of the abstract algebra. That is, first, given a concrete example, mathematicians try to set up an algebraic structure for it. And then they will study the properties that the algebraic structure has. And then they will apply these properties to concrete modules. And this is a general idea of the abstract structure.